Hello, welcome to yet another episode of our sequencer series, and our main focus is arithmetic sequences. All right, so in this case, we're gonna start with the definition, and we know that an arithmetic sequence, sometimes is called a linear sequence, is one that is of ordered numbers, okay? But what is important is that this sequence can be obtained by either adding or subtracting a constant value, okay? So in this case, we're just using adding because that constant value could be of a negative number, okay? Then the subtraction will be taken care of. All right, so we know that the general term, okay, the general term, which is the general rule or the nth term of an arithmetic will be given using this Tn is equal to a plus n minus 1 into d. So the n minus 1 must be in brackets. All right, so what we know is that the a will represent the first term of the sequence, and then n represents the position, okay, of the term, and then d will represent what we call the common difference. Now remember, in any sort of sequence, let's say we have 2, we have 5, and then we have 8. Okay, so we say 8 and so on. So for as long as we have a constant difference between the two or between the consecutive terms, then this would be an arithmetic or a linear sequence. So what we're saying is that every number that is within the sequence, okay, these are what we are calling the terms. So first term, second term, third term, and so on and so forth. All right, so let's see how we can work around with the arithmetic, just the simple calculations. All right, so given the arithmetic series, we have 12 plus 6 plus 0 minus 6 and so on and so up until 200 terms. Can we write down the next term of the series? So what we can notice is that the numbers are decreasing. It's a minus 6. You can say for us to get the D, it's a T2 minus a T1. Or you can get a T3 minus a T2. That's how we get the common difference here. So if we get a 6 minus 12, we get negative 6. And then the 0 minus 6, we also get a negative 6. And then negative 6 minus 0 is negative 6. So which means we're going to subtract a 6 again, and then we end up with negative 12. And then they want us to calculate the 161st. I don't know why they're saying 161st term of the series. So what we can do, we need to first of all determine the Tn. Okay, then after getting our Tn, then we can be able to find the T161. Okay, so what we're going to do, we're going to say that our Tn is a plus n minus 1 into d. So our a was a 12 plus n minus 1. Our d, we're saying is a negative 6. So this is our Tn, or we can just simplify this further, and then we shall have 12 plus, no, that's going to be negative 6. Okay. So minus 6n, and then that's going to be a plus 6. So that will give us our Tn as 18 minus 6n. Now, since we're looking for 161st term, it will be T161, which is 18 minus 6 times 161. All right, so we go to our calculator and then just punch that into. So 161. So I'm getting negative 948, and then that becomes our answer. All right, question number 2. I'm telling us that an arithmetic sequence has the first term equal to 7. Okay, so our A7, and then T15 is 35. Can we determine the value of the 8th term? All right, so step number 1, I'll have to get the Tn value. Okay, the formula. We said A plus open brackets n minus 1 into d. We know that our A is a 7. Okay, so that's going to be 7 plus n minus 1 into d. I'll need to get the value of d first before I get the remaining terms. So let's see, how about T15? So T15 is gonna be 7 plus, that's gonna be 15 minus 1, which is 14 with a D. Okay, but the T15 is 35. So where there is T15, I'll replace the 35 and say 35 is equal to 7 plus 14D. Let's transpose the 7. So 35 minus 7 must give us a 28. Okay, is equal to 14D. Divide both sides by 14, which means our D value is a 2. Then if the D value is a 2, then we can go ahead and find the T8, which is going to be A plus 7D. Because it's going to be A plus 8 minus 1, which is a 7, and then D. So we know that our A was a 7 plus now 7 times 2. So that's going to be 14 plus 7, which is 21. So T8 becomes a 21. All right. Then 2.1.2, determine the number of terms in the sequence if the last term is equal to 155. So Tn, being the nth term, could represent the last term. So in this case, our Tn is 155. What do we need? We want the number of terms, which means we need the position where the 155 is placed. So we shall go back to our Tn formula and say Tn is going to be 7 plus open brackets n minus 1 into 2, because it's the same question. If we are to open this up, it will be 7 plus 2n minus 2, which is going to be, do I need to do all of that? No, it's not really necessary. I can just do the substitution straight away. Just set. Okay, so where there's Tn, I'll replace with 155 is equal to 7 plus 2n minus 2. Then let's transpose. Okay, let's first solve this and that, which is a 5 now. So it's going to be 155 is equal to 5 plus 2n. Let's transpose the 5 to that side, which is going to be just 150 is equal to 2n. Then divide both sides by 2, and then our n becomes 75, which means we have 75 terms in this sort of sequence. All right, question number 3, example 3. Consider the following sequence of numbers. Okay, so we have this, that, and that. If the first 3 numbers form an arithmetic, okay, so in this case, I'm only going to focus on the arithmetic part. And then the last 3 numbers form a quadratic. Okay, so these ones form what we call the quadratic. The first 3 arithmetic, can we show that x is equal to 7? Okay, so one thing we know about the arithmetic is that there is only one difference, which is constant. Okay, so if I have 1 minus x, and then I have 2x minus 11, and then I have x plus 5. Let me get the first difference there. Let me get the difference there. Now, if I call this difference 1, this is going to be my difference 2. At the end of the day, D1 must be the same as D2, since it's arithmetic. So let's do the subtraction first. For us to get D1, it will be T2 minus T1. Okay, so 2x minus x, that's going to be a 3x. And then negative 11 minus 1, that's going to be minus 12. Okay. And then x minus 2x, that's a negative x. And then 5 minus 11, that's going to be a positive 16. Okay, so then what I'll have to do now is equate the two, since D1 must be the same as D2. So 3x minus 12 is equal to negative x plus 16. We transpose, we collect the like terms. I move this that side, it's going to be a 4x. When I move this on that side, it's going to be a 28. Then divide both sides by 4, which means our x is a 7, just as the question said. All right. Then 3.2, hence, determine the values of the first 2 terms and the common difference of the arithmetic. All right, so the hence part simply means from where we stopped, okay? So we have proved that our x is a 7, okay? So all we have to do is substitute. Where there is x, let's put a 7, okay? So we know that 1 minus 7 is going to be a negative 6. All right, then if we have 2 times 7, which is a 14, minus 11, that's going to be a 3. So these are the first 2 terms. All right, then for us to get a common difference, remember we said T2 minus T1. So it's going to be 3 minus 6, and that gives us a 9. So our D is a 9. Our first term is 6, and then our second term is a 3. All right, so that is question number 3. All right, question number 4. Question number 4. They're telling us that the 5th term of an arithmetic is 0. The 11th term is 18. Can we determine the general term? Lord, what are you going to do? So they want the Tn, okay? But from the information we have, we know that T5 is 0, and then T11 is 18. Chances are high we're going to have to solve this using the simultaneous part. Right? All right, so let's see. I'll put it this side. So we say T5 is 0, T11 is 18. So we know that the general term of an arithmetic is A plus n minus 1 into brackets multiplied by D. All right, let me start with the T5, okay? We don't know the value of the first term, so I'll keep the A plus position is 5, so it's going to be 5 minus 1, which is a 4D, okay? But they told us that this whole thing is equal to 0. So where there's T5, I'll replace it 0. So that my expression becomes A plus 4D is equal to 0. Let me call that equation 1. Then when I come this side, we know that T11 is going to be A plus 11 minus 1, which is a 10. So that's a 10D. But this whole thing must be equated to 18, which means A plus 10D should be equal to 18. This is our equation number 2. Now I can choose to make A the subject and move it that side, move 40 that side. So from equation 1, our A is going to be negative 40. Transpose the 40 to that side. So call this equation 3 or equation star, which I need now to substitute into that. So it's going to be negative 4D plus a 10D is equal to 18. Negative 4D and 10D, that's going to give me 6D is equal to 18. Divide both sides by 6, which means D is a 3. What is the question asking for? Question is asking for the general term. So for us to get the general term, we have our D as a 3. We need to find the value of A. So A is going to be, we say, negative 4 times the D, which is now negative 12. All right, so our A is negative 12. So we know that Tn is A plus n minus 1 into D. So if negative 12 plus n minus 1, we say the D is a 3. Let's open this up. Okay. Let's open this up. So you can give it as that, but we always prefer a simplified version. So negative 12 plus 3n minus 3, which is now negative 15 plus 3n. Or somebody can write it as 3n minus 15. So this is what the question wanted. Then part B, calculate which term has a value of 165. So if the Tn is 165, what is the position? Okay, so we have this Tn formula, can just substitute. Now this Tn, we replace with 165 is equal to 3n minus 15. All right, then from there, let's do the transposition. I'm gonna move the 15 that side. So 165 plus a 15, that's gonna be 180. So 180 is equal to 3n. Then I'll divide both sides by 3. So which means in position number 16, we shall have a value of 165. All right, so that is that with that part, okay? So I think I'll stop there with the arithmetic series. So that is it. Let's meet in the next video where we shall be talking about the geometric and so on. Bye-bye.